do we mean hardware specific for the system architecture? And that's exactly right. And the notion here, it's actually, I think, very important. And this is where I feel like there's a little bit of a disconnect with many of the AI systems that happen today, is these are really interesting systems with a lot of merit in their sort of abstract scientific application. But if they can't be realized in a physical world on actual hardware that is fully exercised and running at a high degree of efficiency, then it's not likely that these systems will be able to function at the scale that I think many of us want them to. Like, I think a lot of people are thinking AI is going to be the next big thing. It's like that. It's as big as the internet, and I think for sure it can be. But if we don't have the right mappings to lower level hardware, like if all we're writing are very high level abstractions that are in languages like maybe Python, while that's good for the concepts, that's likely several orders of magnitude too slow for it to scale where every person on the planet has their own 100 models that are helping them with their food tastes and their code tastes, the types of cars they like, the types of dogs that they like, what their sleeping and eating habits are. If we want to get to that level of ubiquity, again, like we have with the internet, where we have so many devices that this has an IP address and that has an IP address and this is Bluetooth, and it's easy to forget about that because it's designed in such an elegant way, and it's so scalable by the core architecture that it can be ubiquitous, and it is. That if we don't make the same type of intentional mappings into hardware, like the way that we're doing with LUMs right now, I think is insufficient for it to reach like a global level of adoption.